My name is Eric Budlong, and I'm the product manager for the AccuSeries analyzer. I work directly for Galvanic Applied Sciences. We are a gas and liquid process analyzer company, so we design everything, manufacture it, as well as support it. We have 30 plus years of experience in the industry, both in North America and worldwide. And we have offices in the US and Canada. So all of our liquid products are made and supported from Lowell, Massachusetts, and all of our gas products from Calgary, Canada. So what we'll be talking about today is what's new about the AccuSeries analyzer, as well as some of the design capabilities, the applications that we can use it with, as well as why someone would consider AccuSeries as their chosen analyzer, and then we'll finish with some Q&A. AccuSeries is a wet chemistry process analyzer, and it can be configured to perform titrations, ISEs, and colorimetric analyses. It's an online analyzer, but it's not a continuous measurement, it's a batch analysis. And we do this in order to conserve reagents, to save on costs, as well as different analyses require some time before the result is given. Think of the AccuSeries as a robotic chemist, so it will do all of the calibrations, the cleanings, everything automatic. So that way you don't need lab techs going out to take grab samples. It does everything for you. And we have two different models of the AccuSeries line. We have AccuColor, which performs our colorimetric analyses, and AccuSense, which does our potentiometric, so the titration and the ISE. All versions of this analyzer are made right in the United States, in Massachusetts. You know, Titronics began in the 80s with the FPA series, and then we moved on to the Sentinel, which had a couple updates, and now finally we're launching the AccuSeries. These are the main points for what's new with this analyzer. So instead of the Sentinel being only suited for a general purpose area, only up to about 45 degrees C, we can now operate in Class 1 Div 2 as well as ATEX Zone 2 areas without a purge. And we can handle up to 60 degrees Celsius ambient temperature without a vortex cooler. So this would cover most applications and save a lot on cost. Calibration, instead of 1 point, we can now do up to 3 points, which increases our accuracy. Communications are greatly expanded to include Modbus, Ethernet, USB, serial connections, and we also have a great GUI. Now, one of the most distinct differences from the Sentinel and AccuSeries is the Sentinel was very fixed to 1 or 2 methods, 1 or 2 parameters. You know, at most we could do a caustic and carbonate. Now we can do up to 10 methods, as well as multi-parameter and advanced methods. And so what I mean by that is the analyzer can store, let's say, an alkalinity and an acidity. So if you ever wanted to reconfigure it in the future, you would just select a different method, put the different titrant in, and be ready to go. Now for a multi-parameter, we have a lot of flexibility with this. The only limitation is the pumps available. So the Sentinel had 5 fixed pumps, whereas now we can do 6 of any variety, either piston or peristaltic. An example of a multi-parameter system could be an acidity, alkalinity, and pH system with 1 piston pump for the acidity, 1 for the alkalinity, and then the pH can be read from the pH electrode. We also have electrode diagnostics now. So when you're calibrating, it will tell you if the slope and offset are correct or not, and it will let you know if you need to do some cleaning or to replace the electrode. Reconfigurations were very difficult with the Sentinel. There was a lot of engineering that went into it. The AccuSeries is very simple. It's all plug-and-play modules. And so each board, the photonics for colorimetric and the potentiometric board, are just plug-and-play. You can also use them both in the same analyzer, so you can refer to them as required. The design of the display, we've made it a more narrow footprint. So space is often a consideration when choosing an analyzer. So now it's only 16 inches wide, and there's a beautiful color LCD with it. And then lastly, the electronics, so all of the boards have a special corrosion-resistant coating, which means that for H2S and moisture, it's not going to affect it. We still have the great fluidic system that's going to give you plus or minus 1% volume repeatability, oftentimes better. which is very critical for titrations and colorimetric analyses. We also have a nice, robust design for long-term operation. So many of you know that our classic FPA series that came out in the 80s, we still have some in operation, which is always surprising to hear. But all of these systems are built to last and last. As long as you take care of them, they will work. For measurement range, we can go down to the parts per billion through ppm, grams per liter, and percent range. And most of the spare parts are universal for the Sentinel and AccuSeries. So the valves, the reaction cell, the tubing, O-rings, etc. If you have any stock of the Sentinel spare parts, you can still use them in the AccuSeries. For the enclosure, as I mentioned, we can go up to 60 C ambient. The IP protection is 66 NEMA 4X, and the enclosure is painted 304 stainless steel. And this can operate in DIB 2 and ATEX Zone 2 areas without a purge. Analyses, multi-parameter. I have calculated it out. I think we can do up to 7 in some special cases. We can do up to 4 streams, and each stream can be multi-parameter, which is another nice feature. 3-point calibration and accuracy and repeatability are all plus or minus 2% full scale. For the fluidics, we have a wide bore sample tubing, which means we can handle higher turbidity as well as suspended solids. Samples up to 70 degrees Celsius, and we can also do hotter with sample cooling or different materials chosen. We have an internal fast loop, so there's always a fresh, repeatable sample. And we have inline dilution available if we need to dilute for higher ranges. As I mentioned, we can do up to 4 streams, and all of these systems have built-in stream harnesses. So if you ever needed to upgrade from 1 stream to 2 streams, all you need is the valve. Everything else is already built in. Flexible communications, corrosion-resistant boards, as well as diagnostics alarms. We have the display board as well as the main board, and everything is plug and play. So on the bottom you can see this is where the photonics module is. We have the source lamp and the different measurement and reference bandpass filters. Right above it is where we would plug in the potentiometric board, so for titration and ISE measurements. Above that is where all of the analog output boards will go. And then above that, the serial connections, RS-232, RS-485, and Ethernet. On the right side of the top is where the 24 volts power source can be plugged in. And then below that we have different modules for Modbus, as well as the connections for all the stream harnesses, piston and peristaltic pumps. You can do a power supply option. So if somebody wants 115 or 220, we can do that as well. We're able to go through the different setup menus, change outputs, play around with the methods. And what's nice is we can actually see all the active components. So on the right side, on the red image, you can see piston pump 3, 2, 1. So when you put your mouse cursor over it, it will actually appear, which is very handy. You have 3-way valves. What this means is that you're going to get on-demand sample flow. When we're not taking a sample, it's either going to go back to the process at a lower pressure or to a waste stream. And so this internal fast loop means it's always a fresh, real-time sample. As I mentioned, built-in stream harnesses, and we have that wide sample tubing for the high turbidity. Reagent pumps, we have 3 different ones that we use. We have a peristaltic pump that we use for fast, large volumes. So this could be a cleaning standard or a buffer solution. This is where we don't really need accuracy so much as fast volumes of a liquid. You can also use this for special applications where we need to do dilution by sucking out sample from the reaction cell. The piston pump is where we get our accuracy for very precise volumes. So this is where we're dosing titrants, color indicators, anything where we need great accuracy. And then we also have a small sample valve loop, the SSV, where we can do dilution up to 100 times and sometimes more. So for very high concentrations where a specific method is required, we tend to use this. The analysis is performed with a very unique sample capture technique, where we overfill the cell with sample and we trap a fixed volume by dropping it down to the required sample volume, 5 mils, 10 mils, whatever it is. And then we add the reagents and perform the measurement. And so what this does is it compensates for any variable flow from old filters or bad flow rates. And this is very critical for getting reproducible results. Looking at the design for the reaction cell, it's a gas-tight bevel design, which reduces the sample required for each analysis. And we also have homogeneous mixing via the magnetic stir. Performance is all between 1 and 2% full scale. When a customer is deciding what calibration range they want, they need to think about where they need the greatest accuracy. If they want the full scale of 10 ppm, but it's very critical at 100 ppb, obviously we want to calibrate at a lower range so that there's greater resolution there. Here we have a few examples of, based on the range, what the accuracy would be. I also have a photo of the display calibration setup menu. You can see it's all very, very simple. You just select whatever you need when performing an absorbance. All of the wetted parts are customized to make sure that their life is extended and so that you don't need to keep replacing parts often. This includes the O-rings, the stir bar, the valve, sensor, and much more. At the same time, each method of analysis is tailored to the specific application. Look at making sure that we're matching the lab, if there's also a measurement performed there, and we look at any interferences that could be possible in the sample. For example, an ammonia measurement, the first question we ask is, are you using an ISC or colorimetric method in the lab? And then if they're doing colorimetric, we dig deeper. Well, is it the Nestler method? Is it the salicylate method? And we make sure that there's no interferences in the sample. We can also do sample conditioning, so if we need to regulate the pressure or the temperature, and in some cases we can do filtration as well. Maintenance is very straightforward and minimal at most. For both systems, on a monthly basis, you'll want to calibrate the flow rates. Quarterly, you'll want to change out the peristaltic tubing, and then twice a year, check the seals, replace the O-rings. All this is included in our standard maintenance kit. So you don't have to worry about getting multiple parts. It's all within one part number. And then if you have a colorimetric analyzer, you want to change out your source lamp and filters about every 1 to 2 years. Then every 2 years you'll probably want to change out the reflector and the light shield versus a potentiometric analyzer where the sensor is probably 1 to 2 years you'll want to change out. For methods of analysis, we can do 3 different flavors. First is a dual wavelength colorimetric analysis, which has turbidity compensation from that second reference filter. We also have FPGA signal resolution. And so this is field programmable gate array, and this is used in cases where you want to move a difficult analog measurement that requires great precision to a digital domain. And so basically by using this, we're getting better sensitivity and repeatability, which means better accuracy. And so you can think of this as a hardware auto adjust. Then for ISEs, we can do direct measurements, very similar to a pH measurement. And we can do a standard known addition, where we add a known quantity of standard, measure the total, and then subtract that to get the result. Then finally, we can do potentiometric titrations, whether it be acid-base, redox, or gentometric. And then for the reagents, we always aim to choose reagents with a long shelf life, and they can be purchased through Galvanic, or you can formulate your own. So a little theory about the colorimetry. A color is stimulated by adding a reagent, and it's read in the visible spectrum from 400 to 700 nanometers. Based on the Beer-Lambert law, it's a dual wavelength measurement, so starting at the source lamp, the light travels through the window to the sample to the reflector, then back through the sample to the detector, and this is going to correct for turbidity. ISEs, in this case, it's a potentiometric measurement of a specific ion, and so it's a voltage potential change that's proportional to the concentration of what we're measuring. We achieve this using special ion-sensitive membrane material, and so it could be a solid state, liquid, gas, or glass membrane. So an example for a fluoride ISE would be using an lanthanum crystal membrane. The sensor is either configured as a combination where the half cell and reference are in the same chamber, or we can do it where they're separate. It all depends on what we think is best for the application. And again, going into some theory, this is all based on the Nernst equation. Lastly, titration. This is a volumetric determination of an unknown concentration. So an unknown concentration of an analyte. First, we add a titrant of a known concentration, which reacts quantitatively with our unknown, the analyte, and then we determine the equivalence point by the end of the titration. So the equation below demonstrates how we can calculate the concentration. And something else new about the AccuSeries is we can now perform back titrations, which opens up the doors to some different analyses we couldn't do before. As for the endpoints, we can do fixed, relative, and derivative endpoints. So looking into applications, AccuSeries can be used for a wide range of different markets. Beverage, We can measure the source water as well as clean-in-place, steam-in-place systems. An example of this might be a brewery making beer, and they might have two different locations, and they want to make sure the beer tastes the same. So they might monitor the source water to make sure that the parameters for hardness, alkalinity are all the same. Clean-in-place might be measuring the residual for hypochlorite, chlorine, some kind of disinfection. Biofuel, so for the pre-treatment stage, digester, bioethanol, biodiesel, so they might be looking at the acid and base numbers for product quality. Boiler and cooling tower, so in this case, disinfection, whether it be hydrogen peroxide, chlorine. Coagulation, so monitoring the alkalinity to make sure the pH change isn't too severe, as well as scaling and corrosion prevention. So perhaps looking at sulfite, oxygen scavengers like hydrazine, as well as any scaling from salts, sodium, silica, hardness, etc. Chloralkali has many different applications we can work with. So for the brine purity, looking at the hardness in brine. We can also do speciated measurements, so both at calcium and magnesium. We can look at the chlorine as well as EDC for different quality parameters. For fracking, we can look at the injection water and produced water. So if we need to measure any sulfide or any other contaminants that might be in the water. Municipal water and wastewater, as long as the solids aren't too high, we can do a wide range of measurements for all the different EPA standards and environmental compliance for the local permit. So nutrient removal might be the nitrogen and phosphorus. The disinfection will probably be chlorine. For electroplating, surface finishing, rinse tanks, plating baths, wastewater are common applications. So all the different metals as well as the different acids, so sulfuric acid, phosphoric, and then the nickel, copper, chromium, whatever's being plated. For the power industry, we might look at the flue gas scrubber, where we're monitoring the amine strength, or turbine oil for a quality parameter for the acid and base number, as well as the steam circuit and cooling water for scaling prevention. Pulp and paper could be either the process water or the pulping stage, so we might be looking at chlorine dioxide or sulfide. And then for refinery, could be sodium in the desalter, gas sweetening, so it could be the acid gas loading, sulfide loading, and then in the petroleum quality, that might be acid base number. Then sour water, ammonia. SAGD, that's the steam-assisted gravity draining. So we might look at the makeup water, produced water, lime softening, or weak acid cation exchange. So that could be alkalinity, that could be looking at the hardness, as well as many other parameters. Semiconductor, we could look at the etching baths. So again, that's those metals, acids, there might be some surfactants. We could look at the photoresist stripping as well as cleaning stations for any residual chemicals. Sugar could be both cane or beet, processed water, as well as textile for bleaching, dyeing, so looking at any disinfectants or surfactants. And then here's an overview of the main parameters that we can measure with AccuSeries. We're not limited to this range, but these are the most common ones that we see. So considering why choose the AccuSeries, we're able to replace several analyzers with one because of the multi-parameter and multi-stream functions, which means a fast return on investment. And by switching from the lab to an online measurement, you're ensuring trouble-free operations. This means you minimize human error, you're going to be able to reduce any extra plant emissions by catching issues before they become costly emergencies, and you're going to achieve competitive advantage. So if the other chemical plant is using lab analysis and you're online, that means you're going to be faster, more flexible, efficient, cost-effective. Your product quality is going to be better, and you're going to avoid costly interruptions. Going about AccuSeries as well as Galvanic as a whole, we have very good service support. We can do scheduled maintenance, factory acceptance tests, local on-site startup installation and training, and if any advanced training is required, we can do classroom sessions as well. So considering why to choose Galvanic, we're application specific and customized. Everything's tailored to your specific needs. We have a global presence and long install base, as well as very local support with our distribution partners. And lastly, as I mentioned, you're going to see a fast ROI when you choose Galvanic.